everybody, it's Bruce at Groxio Learning, and I've got the dog on the floor, and today we're going to be talking about SVG graphics. So we'll get to start to see a canvas take shape for our application. And as you recall, we've been working on a project, and one of the things that I'm going to start doing is tracking checkpoints. So you can see which Git branch that we're working on. So we are actually in a Git project. So I'm going to go to github.com, and I'm in Groxio Learning with a hyphen, and we're in quad block 2. So you can see that we have a couple of branches here. So this is the master branch, and this is checkpoint 1. And checkpoint 1 already has the things that we've built so far. So if you recall last time, we started working on our live view. So if I'm looking in the live view is in game.live, and you can see a couple of the functions that are important to us. The first one is mount, where we create a new tetromino, and that's a reducer because this takes a socket and returns a socket. And so all of the reducers on this module will be over the data for the module, which is a socket. So the socket's the data for a live view. When we want to present the socket, and live view does this automatically every time our socket changes, then the render will be called. And when we want to change the socket, we'll process events. Like for this one, we move the tetromino down. Okay, so one of the things that we're going to do is render all of the points related to a tetromino. So that means that we need more data than just what's there. So what I'd like to do is have a special reducer on the socket. So that's something that looks like this new tetromino. And in fact, I'm going to make this a private. So let's go ahead and do that now. So we're in Game Live, and we're going to make this private. We're going to move things around a little bit. We're going to move this down so that all of our reducers related to render are at the top end up here, and all of our reducers related to handling events are down here. So I'm going to create a new reducer called show. And the job of show is to add points to the live view. So here, I'm assigning to the socket. We're going to add points. And right now, we don't have a function to get the points that we need. So we can do that work here. Okay, so we're going to get the points from the tetromino. And where are we going to get the tetromino? So we're going to get that from socket assigns.tetro. Great. So I'm going to shape this a little differently just so we could see exactly. Sometimes I even move the socket up here because these are the things that I need to worry about, all the individual assigns that I'm dropping in. Right? So now, anytime that I'm ready to render, all I need to do is fire everything through show, right? So we're getting, so the tetromino looks like this. Now we're going to be, so let's see, the mount, we're piping here, so let's also pipe that to show. So we haven't written that points function, and in fact, we don't really quite know what that looks like, but we can give it an initial approximation just so that we could start to have some points to work with. So I'm going to go into tetromino, and we're going to create this function called points. And this is going to take, like most of the functions in this module, it's going to take as the first argument the thing related to the data for this class, which is a tetro, which is a struct. So we can basically, for now, just so we have a point to work with, we'll create this list and we'll call that tetro.location. So let's go back. So now we can start to render this. Let's see if everything is compiling and working okay. So this is our file, localhost 4000. See if our server is still up. Yeah, it is. And I'm going to go to game. And you can see that this is moving down. So I'm going to change this piece to actually render our points, which is more interesting. Now, so let's open up game live. So in here, now we should have a point to work with, right? So because in this show reducer, we added points. So that's a lot more interesting to look at. So let's say, this is the shape of the thing that we're going to get back. And let's say that we're going to, we're going to grab this line. And so let's say that this is the shape of the thing that we're going to get back. Remember, this is a list now, and this is in points. Okay, let's see what's happening here. Points not found in tetramino. Oh, we're passing location in, aren't we? So tetro.points. So what's there that we got? It says points not found in tetramino. Okay, location. Okay, so this is the tetro, right? But we want points. Yeah, so I don't know where I was going with that. So this is actually one of the attributes that we added to the reducer. So we mounted, and then we got a new tetramino, and that added the tetro to the socket. And then we added the show, which added the points to the socket. And the reason we call this show is we're essentially taking what we have and getting everything ready to render. So now we can try this again. Key points not found in, so that's still, I haven't saved. Okay, and this can also be saved. Now, there we go. Okay, so this is the points. So one of the things that's interesting is we are getting a point there, but it's not changing. Why? Because we're basically dropping the points in only once when we create this thing the first time. So this is the function that takes the tetramino and dumps the points out. So one of the things that's interesting here is now in down, we can start to basically play this as a story, because we've shaped our code in reducers, right? And so this is the move down, and then I can say get ready to show everything. So drop the points for the move tetramino into the socket, right? So this puts the original this moves the tetramino down one, and this takes that tetramino and drops the points for it. Yeah, take a look at that. So this is moving down exactly as it should. Perfect. So now we're going to start to play around with SVG, which is a vector graphics format, and that's going to allow us, so SVG rectangle, this is going to allow us to build our points. So let's start with a canvas. This is what a rectangle looks like. So this is the rectangle here, this is the canvas. And let's do a little bit of mental math. So say our tetramino is maybe a 20 by 20 square. then if a Tetris board is 10 wide, that should be 20 times 10, which is 200 wide and 400 tall. So let's go ahead and drop that in. So I'm going to go ahead and render the board. Render the game board just like this. And I'm going to pass it the whole assigns. And maybe this should be inside the hero. Maybe we should have a welcome to Tetris. And we should render the board just like that. And so we're going to need a function to render that board. This can be private since we don't want to export this. This is going to take an assigns because we want to use this LiveView sigil. And anytime that we have this LiveView sigil, we're going to need to, it's going to need to support assigns. And so we're going to take in here and we're going to drop this rectangle. Okay, so let's take this rectangle and build it like that. That's nice, just like that. So this is going to be, what did we say, 200 wide and 400 tall. So that's if every point is 20 by 20, then it's going to go 10 of those across. A Tetris board is 10 wide, so that's 200. 10 times 20, which is 200, and it's 20 tall, so 20 times 20 is 400. And so let's build a rectangle. And so let's say the width of that is, well, it's all 200, and the height is all 400, and the style is going to be, I'm going to fill it with RGB, so we can make it black like this, right? Style fill like that, and the stroke, I don't think I need a stroke on there. So that's if I had like a, let's see what that looks like. And so I need to close out the rectangle, which that does just fine like that. So let's see what this looks like. Okay, so there's my board, and now I can put a point in there. So let's hard code the point for now. And this is going to, actually, no, I don't think that we need to hide this at all. So I think that we could go straight to, well, no, let's start with just a simple point. So I want to draw another rectangle on top of the first one, and that's going to be have a width of 20 and a height of 20, and a x equals, let's call that 0, and a y equals 0, and the fill, what is it, RGB, right? So red, if it's S255, this will be bright red. Okay, and there's a point. So that's interesting. So that's something that we can work with. But what it would be nice to do is actually take the point that's in my SVG and work with it right in line. So what we're going to do is, so I want to take a look at this in a bit and see if we're doing everything okay. But basically what I want to do is there are points in here. So maybe what we want to do is we're going to say render point, right? And that's going to take also Great. So that's going to also take the whole assigns. And then I can take this and we can basically build it structurally like that. So I'm going to say def p render points. Okay, so this is going to also take a live view sigil like that. And I'm going to drop in this code. And so we need the X and the Y here. So the assigns has something called points in it. And I'm just going to do a cheap trick right now. So I'm going to say the points has this shape. X, comma, Y. So now I have an X and a Y that I can work with. And this is going to actually be, that's going to be, actually it's going to be 2020 anyway, isn't it? But the X is going to be, so if it's 0, so let's go ahead and render this at X times 20. Do we like that? And then, so this is going to be off a little bit, but bear with me, we'll adjust it in a second. So I think I'm going to actually break this out like that. Have X and Y and the height and width on one line, and then the style on another line. I think I like that pretty well. So this is saying we're going to render X, so every point is going to be 20 wide, so we want to render that a little bit wider than normal. And I don't see my point on there, so we better look at this and see what's happening. So I get a rectangle, and then it doesn't look like I'm rendering my points anywhere, does it? So this is the initial rectangle, and here I'm rendering the points. And that's actually going to take assigns and render all of this stuff. Oh, is that breaking like that? Nope, because this is X and Y right here, right? So let's see. What if we didn't plug any of this in? What if X was 0 and Y was 0, like that? Does that fix my problem? Yeah, so I'm rendering the point there. Okay, so what I'm not getting is, so something is breaking down with this. So, so I want to know, I want to see if I can get a, and then I want to see if I'm actually getting this data here. Maybe a comma between those, that'd be nice, right? So render points. So let's do a io.inspect or io.puts. And then let's use the sigil for the string because this has quotes in it. And I'm wondering if we can get this to print out to the log here, right? So is this crashing at all? It doesn't look like it's crashing at all. Yeah, so this is moving 20 over and 20 down. So that's not at all what I want. So, but I am getting a red line there, so that's nice. So, okay, let's make sure that we're still getting what we expect to here. Okay, so that's still getting a red line. So let's work on the math a little bit. So this is the offset that we need. So I bet that I need to be X minus 1 times 20. And I bet this needs to be Y minus 1 times 20. Let's see if that drops us in the corner there. Okay, beautiful. So that's basically moving down like it should, and it looks like it's starting halfway down, which is at 5. Let's rerun this much. Yeah, so we're starting at the top and we're moving all the way down the page, which is pretty cool. So what I'd like to do now is actually, once we get to the bottom, let's see if we can make it go down instead. So I think that we can do that with a pattern match. So what if what we're getting back is a tetromino with a location at something and 20. What if the location is all the way at the bottom? What do we want to do? So let's instead do a socket and let's assign a new tetromino. Let's just build a brand new tetromino up there and then drop that from the ceiling. And let's see if that works. Yeah, so now we're dropping it. So let's talk about exactly how that's working. So we have two clauses. So if this thing is moving down and gets all the way to the bottom, so if the Y value in the location, so we're pattern matching out assigns. Well, what's in that? We have a tetromino and we have points. So let's grab the tetromino. And if the location, if the Y value is 20, this is what we're going to do. We're going to take the socket, pop in a new tetromino, and then do a show. And then we get an overall impact that looks something like that. And that's great. So, and in this case, if this is not true, I'm going to pick up the second clause, which is going to take the socket and it's going to move the tetromino down and it's going to call the show. So what I don't like is that this is at a different level of abstraction. And what that means is that what we're doing is essentially we start with a socket and then we have a low level function and then we have a high level function right here. So maybe what we want to do is do this move here and say this one, let's put back exactly like this, assign socket the tetromino like that. And maybe this should say socket down and show like that. Let's see if we like that design better. Okay, so that's still working, but now it's a lot easier to read my intent. So down only has this single responsibility. And now in the handle info, I can play back exactly which reducers that I want to call. I like that design quite a bit, actually. So this is probably a good place to wrap up and call it quits. So what did we do? We basically decided that we wanted to render something, but we wanted to render something more beautiful. And the nice thing about LiveView is that it works, everything that it works with is a string. So what we can actually do is we can see the string that's actually being rendered. So I'm going to go IEX mix like that. And now I'm going to actually render what we have, right? So I'm going to say the socket, and I'm going to make that as a new default socket, right? So remember, when you're building a struct, I need the structure here. So that is Phoenix LiveView .socket. And so that's going to give me a default socket. And what does ours need in it? It needs an assigns with a tetro. And that is, or actually, we can actually use the reducers that we already have, right? And so I can say, for example, So mount is going to return a socket. So now I can say the Tetris web dot live or game live dot mount, and that takes something there, params, and maybe a session and a socket. Yeah, and look what this did. This added the points in the tetromino right here, right? So let's say my initial is just like that. And then I could go down and I could call my individual reducers, the show and the down, and the new tetromino to add whatever I wanted to. But to do that, I'm gonna have to strip the p's off. So we won't do that now. But you can see that this is just a reducer, and that render is just a function. So all render does is takes a single socket which has an assigns in it and builds this, right? And we can call additional functions if we want to. We could do basically whatever we want there, right? And then after we decided what to render, no understanding that this is just a string. So, what we didn't do is we didn't say game. So Tetris web.game live.render. So all we need is our socket, right? So initial So this needs an assigns. I attempted to apply assigns on, okay, I see. Our initial socket, I'm wrong, aren't I? So this says initial socket. And what this needs to be is okay in the initial socket. So now I have in a socket, and now I can actually render, right? So I can say tetrisweb.gamelive.render, and I could render that assigns just like that. And look, what we get back is basically a string. And since this is a string, the nice thing is that we can do what we would like in that string. Like one of the things that we can do is render something which isn't really HTML, but which is SVG, which is a graphic. And that's the technique that we're relying on to render our points. Okay, so in the next session, we're going to basically take these simple points and we're going to group them together so you'll be able to see the individual Tetris shapes for the first time. So this is Bruce for Groxio Learning with the dog on the floor, and we'll see you next time.